All right, so we've talked about functions, right? Domain, range, how to figure those out from the graph. And we've talked about linear functions, right, a little bit, like f of x equals mx plus b, right? But today we're just going to focus more on just sort of, well, I would say geometric or, yeah, I say geometric questions involving lines. But geometric in the sense of analytic geometry. So, what is analytic geometry, by the way, guys? What do I mean by analytic geometry? What's analytic geometry versus, people used to talk about, or sometimes people still talk about synthetic geometry? Or axiomatic. So like axiomatic geometry is very old, like Greeks, like Euclid, right? Euclid's Elements, it's like 2,000 years old. We've been teaching it to elementary school kids, well, middle school, high school kids for hundreds of years. It's like part of the classical education, right? These, you remember what I'm talking about? Like the compass straight edge constructions. Anybody take a course in high school like that? Where you do these proofs based on a simple, like, well, a limited list of axioms. And so you have things like, I'm trying to remember a good example. If you have parallel lines, you have a line cutting through those, you know that like the angles have to match up. I'm forgetting the technical term for it, but that kind of stuff, that's axiomatic geometry, right? In contrast, analytic geometry is what we typically talk about in our coursework here, which is geometry which is based on equations. It's based on the interplay between the Cartesian plane, like x comma y, and writing equations in terms of y and x. So analytic geometry is very easy to understand because it just involves equations and this correspondence we have between the point and pairs of real numbers, right? Which is really a much more productive way of studying shapes and stuff than that older axiomatic way. So I always say something disparaging about axiomatic geometry when I have a chance. Anyway, I don't know why I'm telling you guys that. Just point of context. Everything we're doing in here today is analytic geometry. All right, but we're going to talk about lines and equations of lines. So let me remind you, what's our go-to tool? If we have slope m and y-intercept b, well, technically the y-intercept is the point what? 0 comma b, right? Then the formula is what? Y equals to mx plus b. That's the line which has slope m and the y-intercept is there, right? And how do you get m? What is m? It's the slope of the line. It's also the rise over the run. I also say it's delta y over delta x, which is just a shorthand for saying pick 2 points, y2 minus y1 over x2 minus x1. That's the slope. Right? Pick a pair of points, we can calculate the slope on the line. The other major tool that I like to use in here is the so-called point slope formula. And so that says if you're given, say, x1, y1 on line, and slope m, then the equation of the line is y equals to y1 plus m times x minus x1. Right. Now there's a couple more facts I need to share with you today, but I'll wait once we've done a few problems before I introduce those new ideas, namely parallel and perpendicular. We'll get to parallel and perpendicular lines here before too long. So let's start with an example. I'll make this example easy. Consider y equals to 3x plus 8, right? A, find the slope of the line. B, find y-intercept. C, graph it. You're like, I thought you said this was an easy question. This has 3 parts. Not too easy. The reason I say it's easy is because all you have to do is look at it to answer it, ignoring part C. So can you guys tell me what's the answer to part A? Yep. M equals to 3. I heard the y-intercept is 8, right? And how should we graph this line? So on your quiz or test, I will provide a little graphing area. We'll have like grid lines with like little numbers marked on it already. So that'll be provided. So let me try to kind of pretend like we're on your test for a second here. Well, I think I got more grid lines on the one on your test. I think I got more like an 8 by 8 grid on yours, but I'm going to do, I'm going to just have to make these bigger because I can't. I'm going to make this 4, and this is 8. This is minus 4, minus 8, 4, 0, minus 4, minus 8 down here, if that makes sense. So one point we get practically for free, right? Yeah, 8, 0, yeah, 0, 8, which in my report, goodness gracious, God, fine, it's annoying. It's like all the way up here. Hey, let's make the other point on the line. Let's find the x-intercept for this line. How would you find the x-intercept? How would we do that? Where's the x-intercept? It's where it intersects the x-axis, right? What's the equation of the x-axis? It's y equals to 0. So we set the equation for the line equal to 0 to find the x-intercept. So we want to solve 0 equals to 3x plus 8, but we already know how to do that from day 1 in here, right? So I get minus 8/3, right? That's my x-intercept, which I'm going to use some decimal. That's about what? Minus 2.66 repeated, something like that, yeah? It's 2 2/3. Oh, that was a mixed fraction. I try not to do that. But yeah, it's 2.66666. Oh, sorry about that. And then, so that is roughly, right about here. That's where the x-intercept is, right? And so then, to make the graph of the line, just connect the dots, right? There it is. Now, to graph the line, did we have to find the x-intercept? Certainly not, right? You could pick any other point you like and go from there, right? So. Come on. Let's see, find equation of line through 4 comma minus 2 and minus 2 comma 6. So how should we do this? What do you guys think? What's a good starting move? Find the what? Find the slope? Yeah, I think that's a good place to start. So m, so we're supposed to say y2 minus y1 over x2 minus x1. So I'm thinking of that as being the second point. So like y2 I'm going to say is 6. And y1 is minus 2. So I got minus a minus 2. X2 is minus 2 minus 4. So we got what? We got 8 over minus 6. Let's see here, that's 4 times 2 over minus 3 times 2. I can cancel the 2's. I got minus 4/3, right? Minus 4/3 is my slope. And then let me add a little bit of instructions here. Give answer in slope intercept form. All right. So what do you guys want to, what's the next step we want to make here? I see two choices. The one choice would be to use the slope intercept form and to plug the point in, or one of the points in, to figure out what the missing ingredient is, right? I don't have a point with 0 in the x coordinate, so I can't just immediately tell you what b is, right? We have to figure it out. That's the one way. So we could, actually, let me show you both ways, and you can decide which way you think is best, all right? So here's what I've typically been doing in here. I use, oh man, this marker is not long to live. I use point slope. Really? This is new. So I'm going to use point slope. I've got m equals minus 4/3. And you can pick either point you want. I'll use the minus 2, 6 point. Ah! Almost off the ricochet. Phooey. One of these days. So let's try that again, but with a marker that works. Use point slope. We've got m equals minus 4/3. And you can pick either one. I'm going to use the minus 2, 6. So then y equals 2, 6 minus 4/3. X minus a minus 2. In other words, y is equal to 6 minus 4/3 x plus 2. Now, since I'm asked to give my answer in point slope form, I'm not done, right? I need to write it y equals mx plus b format. What do I need to do? Did I hear? Yeah, multiply, distribute, right? Yep. Supposed to be, which one? This? Is that a 6? Yeah, I hope so. Here, I'll make it bigger. Yeah, sorry if my writing gets too small. I try not to. So we've got y equals to 6 minus 4/3 x minus 8/3. But 6 is how many thirds? 6 is 18/3. Yep. Okay. So how many thirds is 6? I think 6 is 18/3, right? So 18 minus 8 is 10. I've got 10/3 total. So there you go. That's slope-intercept. I can tell you that the y-intercept is 10/3. And I can tell you that I know the slope is minus 4/3. So that's one way we could do it. Use point slope and simplify, you know. The other way we could do it would be to just kind of do the algebra. So the other way is just to use y equals mx plus b and find b. So, all right. We know that m is minus 4/3, right? So we also know that minus 2 comma 6 is on line, right? I should say on the line. On line has come to mean something else. On the line. So that would be what? 6 equals to minus 4/3 times x, which is minus 2, plus b, which so I'm pretending we didn't do the blue right now. So like, imagine yourself in the world where we have not done the writing in blue yet. I'm showing you the another way to do this problem. So if we just use the y equals, why am I still wearing this mask? If we still use the y equals mx plus b, then I plug the point in, right? So 6 is equal to, m is minus 4/3, figured that already. Minus 4/3, the x value is minus 2 plus b. And then I just have to solve for b. What's b equal to? Well, this is going to be minus is a plus, right? So I got to subtract it to the other side. So I get 10/3 when I work it out for b, and then I have to complete the thought. So thus, y equals what? Minus 4/3 x plus 10/3. Now which way is easier? I mean, personally, I think they're just about the same, honestly. If you're not burdened with the instructions of leaving your answer in slope-intercept form, the blue way is easier, because if you don't have to put your answer into slope-intercept form, you could actually say, I'm done right here, right? Done. If I can leave answer in, any format. Right? So if you look at that, this is actually the easiest solution if you're allowed to leave your answer like that, Like, are you allowed to leave your answer like that? Well, yeah, in my classes. If you take calculus with me later, some of you might. If I ask you to find the equation of the tangent line, I'm perfectly content to have people leave me an equation for the tangent line like this, because I can see the point and I can see the slope from that, and that's what I'm most interested in. So whichever you like. You do remember, for the quiz, you want to be working on writing a page of notes front and back that you can bring with you to the quiz and help you out, right? So shall we do another example? So let y equals to 3x plus 6. Find where the line intersects x equals to 1 and y equals to 4 graph graph the line. So how are we going to find where this line intersects x equals to 1? How do you do that? Actually, let me go ahead and graph the lines as a starting point. So what's the graph of y equals 3x plus 6 look like? Well, so here's 6, let's say this is 4. I guess that would make this 2. So let's see here. Let me show you another way that sometimes is useful for graphing a line. So we can, if we have 2 points, we can just connect the dots, right? But another way you can plot a line is using the slope and like going step by step, right? Like imagining little triangles. So, okay, so it has one of the points on the line is 6, right? 6 is the y-intercept, right? So the slope is what? Slope equals 3, right? And we can also think that that's like rise over run. So what that means is you can imagine fitting little triangles in, right, which have 1 over and 3 up. And you can use those triangles to kind of like build the line if you can imagine such a thing. So I can think about, okay, so like up, all right, so you don't have to graph all this if you don't want to, but you can imagine like stacking these little triangles and just kind of like going over 1, up 3, over 1, up 3, over 1, up 3, or back 1, down 3, back 1, down 3, and kind of like you can build the line like that, right? Especially if you have graph paper, this is actually how a lot of people think about graphing lines. So, you know, I should at least mention that since we're talking about this. So anyway, whatever method you prefer, there's the graph of this guy, right? So I'm gonna erase those because they're gonna kind of clutter my picture if I don't. Although my line is kind of a bit crooked, isn't it? I tried. What's the x-intercept of this line? Let's make sure I'm being honest. Let's check on my x-intercept. How should we find x-intercept? Zero equals to y, right? So 3x equals to minus 6, x equals to minus 2 is the x-intercept. Looks like I did okay, right? Okay, great. So I go back to my initial question. How do we find where this line intersects x equals to 1? And how can we understand it graphically? What is x equals to 1 graphically? Yeah, you said up, just a vertical line, right? So x equals to 1 looks like this. So the solution set to x equals to 1 is all points of the form what? Anything on this graph, anything on this line has the form 1 comma y, right? Y could be anything. So it's this whole vertical line. Great. Now, how do we find, so the point we're interested in is where? It's where those two lines intersect, right? Where the two lines intersect is where both equations are true. So how do we find that point right there? I mean, graphically, if we'd drawn these lines super carefully, we could look at our graph paper and like kind of approximate it as best as we could, right? We can do better, though, because we're doing analytic geometry where we have both the graph and algebra, right? So we can use that algebra to do the analysis. And can I erase what I've written about the rise over the run here? Everybody good? Because if I write below here, it's like, I know you won't be able to see anything below about right here, right? Yeah. So, x equals to 1, right? So we want to set y equals to 3 times 1 plus 6, right? So I'm plugging x equals to 1 into the equation for the line. That should tell me what the y is, right? So the y equals to 9, right? So that tells me that this point right here is what? 1 comma 9 is point of intersection. Now, how about my other question? How about y equals to 4? Ah, a green marker that actually works. Amazing. So rare. So graphically, y equals to 4 is a horizontal line, right? It's that guy, right? So we're looking for the point of intersection. We're trying to find where the green line and the red line intersect, right? How are we going to find that? We set 4 equal to what to find that point of intersection? (3x plus 6). So to find that point of intersection, I assume that both the thing which defines the green line as well as the thing which defines the red line are both true. I put those together, and in so doing, I have an equation with just x. In the previous one, I put the equations together, I get an equation just involving y, you know? Okay, so that gives me 3x equals 2 minus 2, which gives me x is equal to minus 3 over 2. So the point of intersection, this guy right here, is actually at minus 3/2, comma 4. Now, there is no homework problem like this in your assigned homework. But there could be if, you know, you had a different textbook or somebody had written that problem. I mean, this is like at the level of your course is what I'm trying to say. But it just so happens that this is a problem which was not actually in your assigned homework. But I think it's a useful example for you to see. Okay? All right, so now that we have that, I want to introduce 2 new ideas. parallel and perpendicular. Well, maybe they're not new ideas to you, right? You probably have an idea about what it means for two lines to be parallel, right? Two lines are parallel if they kind of point in the same direction, right? Uh-oh, did I? Poor people following along at home. We've been like here and over for a long time. So what we just went through was that this vertical line intersects the red line here. This green line intersects the red line there. And we figured out that by plugging x equals to 1 into the equation of the red line, which is 3x plus 6, that gave us y equals to 3 times 1 plus 6, which works out to 9. Shows 1, 9 is this point of intersection. And then we plugged y equals to 4 into the equation of the line and solved that and got x equals minus 3 halves, which tells us this point, minus 3 halves comma 4, is that point of intersection. So, what's that? Yeah, go for it. Ah! Oh, man. Thank you. Did I ever tell you guys that a teacher wanted to hold me back in first grade because she said I had dyslexia? True story. My mom said, no, my son does not have dyslexia. People with dyslexia do not have third grade math skills in the first grade. That's what I learned in medical school. You're just too lazy to teach my child. And then she pulled me out and homeschooled me, which was something because it was like the mid-'80s in upstate New York. So like people don't homeschool back then. Not like now. 10% of kids in the US right now are homeschooling, thanks to the COVID stuff. Like people are just like, nah, I'll just teach my kid at home, you know, a lot of people. And that's not even counting folks that are like, you know, public school online and all the other stuff that people are doing. Thank you. Yes, divide by 3, x equals minus 2/3, which means this, of course, is also wrong. Thank you, thank you, thank you, thank you. Much appreciated. Anything else to correct? At the time, the greatest thing about being homeschooled was every so often, as upstate New York, there's this thing called snow. It falls from the sky, it's like ice, and it makes the ground slippery, and you can do this thing called sledding. It's amazing. Most of you are Alabamians. Is that how we say that? How do you say a person from Alabama? What is that? You're Al what? You have no collective name for just Southerners? Okay. But see, in upstate New York, you have to get a ridiculous amount of snow to get school canceled. Like I know, like Virginia and below, if you get a half inch on the ground, everybody and their brother cancels school for like a week, right? I mean, it's just. But in upstate New York, because there's so much snow, you have to get about like this before they'll cancel it, because they got plows and they just go on, right? It's just ordinary business. So I think one day there's about 4 to 8 inches of snow. So we walk over to the elementary school. We're homeschooled at the time. And we go sledding on the hill behind the elementary school. All the other kids are in class. So you can imagine what happened. All the kids are at the window going, and then at that point it dawns on us, uh-oh. So we run away. But fortunately, the teacher didn't get out to take us to detention or whatever. That would have probably been bad. But anyway. You guys okay? You seem like subdued. Something bad happened this weekend? No? No? Just tired? Okay. All right. So as I was saying before I derailed the class, as I will do, we have lines which are parallel, right? So that means that they're pointing in the same direction, right? Like that. These would, up to the limits of my precision here, parallel lines, right? Doesn't matter how close or how far apart they are. The point is that the direction's the same, right? Perpendicular lines look like this, right? They meet, when they meet at right angles, right? They make a nice crisp cross where they intersect. So, come on. So if we have, two parallel lines, and suppose we've got like y equals to m1 x plus b1, and this one down here is y2 is m2x plus b2, versus we have perpendicular lines. So this one could be, say, y equals to m3 x plus b3, and I'll suppose this one is y equals m4 x plus b4. All right. Then we can actually define, even if you like, when lines are parallel or perpendicular as follows, right? So parallel lines have matching slope. In the language of what I have written up here, I'm just saying m1 equals to m2. All right? Perpendicular lines, in contrast, have negative reciprocal slope. You're like, negative reciprocal slope, that does not give me joy, this thing you just said. And so, fine. What I mean by that is m4 is equal to minus 1 over m3. By the way, what happens if you solve that for m3 instead of m4? Like, what if I solve for m3? Like, which one's the negative reciprocal of the other? The answer is it doesn't matter. They're both negative reciprocals of each other. What I mean here is that m3 is also equal to minus 1 over m4. That's just algebra, right? So it doesn't matter which line you start with. The other line, which is perpendicular, has negative the reciprocal slope. Here, I'll show you an example. Come on. Man. I don't know what I've done, but these markers are really hard to undo sometimes. Example 4, I think if you're really having trouble getting to sleep tonight, you can watch my lecture from yesterday, also on lines. And I think I do 2 example 6s in there. I'm trying to avoid that today, because I'm pretty sure that's why they were snickering. All of a sudden they started laughing. And I was like, I'm guessing I had two 6s. So example 4, if we look at y equal to 2x and y equals to minus 1/2 x plus 1, right? So y equals to 2x looks something roughly like that. And y equals to minus 1/2 x plus 1 looks roughly something like that. Well, I've got colors here. Let me use a different color. And these lines are what? These lines are perpendicular, right? Are these lines parallel? What do you guys think? Are these lines parallel? You're like, that's a dumb question. Obviously, these lines are not parallel, right? Do they have the same slope? No. They have negative reciprocal slopes. So can lines be both parallel and perpendicular to one another? I think not, right? These are distinct cases. Is it possible that two lines are neither parallel nor perpendicular? Is there something else that could happen? I think there is, right? I mean, parallel and perpendicular are kind of special, right? Usually, you just take any two old lines, what happens? Like over here, are these lines parallel or perpendicular? Well, I mean, oh, hey, check it out, special case. The green one and the blue one are perpendicular, right? The green and blue meet at right angles. Those are perpendicular. That brings up an important question. What is the slope of the blue line over there? What's the slope of a vertical line? Slope of x equal to whatever constant you like, let's say x naught, is undefined. Because all you do is rise, like there's no run, right? You just vertical, like there's no delta y over delta x. Delta x is necessarily 0. So to ask what the slope is of a vertical line is essentially to ask the question of how to divide by 0. Like we just say that the slope is undefined. Some people will say the slope's infinity. I'll just say it's undefined, okay? How about the slope of a horizontal line? 0. Very good. So the slope of y equals to y naught is just 0. So those are kind of special cases. But vertical lines and horizontal lines are perpendicular, right? So that kind of makes sense as a special edge case of our negative reciprocal thing, right? Like surely 1 over infinity should be like 0, right? You're like, there's some hand waving going on there, but okay, so example 5. Consider y equals to minus 3x plus 2. Find lines, let's say part A, parallel to given line. Fine, I can write out parallel. Parallel. Given line with y-intercept 6 and be perpendicular to given line with y-intercept minus 2. So how do we answer part A? What's the slope of the line we're looking for? We want the slope to match, right? Right? We want the slope to be minus 3. And I told you that the y-intercept is 6, right? So what's the equation for the line? Y equals to minus 3, minus 3x rather, plus 6. There you go. That's the answer to part A. How about part B? Yeah, let's see here. Line perpendicular has m equal to -1 over -3, right? So negative the reciprocal, right? So since we've got -3 slope, we get minus and minus. So there's two minuses, right? So that works out to just what? Yeah, one third, right? So, and b is given to be -2. So we get y is equal to 1/3 x -2. And I could graph these, right? So like we've got the original line, -3x plus 2. The parallel line that has a y-intercept of 6, right? And the perpendicular line, which has a y-intercept of -2. I mean, one kind of good guide for if you're doing a perpendicular problem, right, is like if a pair of lines are perpendicular, one should have a positive slope, the other should have a negative slope, right? Unless they're horizontal and vertical, in which case one should have a slope of 0 and the other one should have, well, undefined slope, right? So there's your example 5. Let me ask a kind of similar question, but make it a little bit trickier. So let's see here. Suppose we have a line, and that line has points which are given, all right? So you guys, you can give me any points you like. Thanks. So suppose line has points, let's say -4, -2, and 3, 1. All right? A. Find parallel line through, let's say here, 4, 0. And then B, find perpendicular line through -5, 3. And then I could say graph all the lines, right? So how should we do this? You guys make me do all the work in here. I would not play poker with you guys. Mostly because I don't know the rules of poker, but also because I have no read on you. Find the slope? Ah, I like that. How should we find the slope? Use the slope formula. Okay, I'll buy that. Let's see here. M equal to. I'll write it down. Y2 minus y1 over x2 minus x1, right? And so y2, let's say, is 1, and y1 is minus 2. So minus a minus 2, and x2 is 3 minus a minus 4. So what do we got? Looks like we got 3 over 7. Yeah. So the slope is 3/7. Great. All right. So now we can proceed to part A, right? So we want slope also to be 3/7, right? Because parallel lines have matching slope. We know that the point on the line is 4, 0. So by point slope, formula for line, I get y equals to 0 plus 3/7 times x minus 4. So I'll just clean it up a little bit. That is y equals to 3/7 x minus 12/7. If you want me to give my answer in slope-intercept form, there it is. That's the parallel line. But yeah, the reason this problem is a little bit trickier is because you're not just given something where you can just read the slope from it right at the start, right? You have to figure that out and kind of go from there. So it's like two-step kind of problem. How about part B? So we want perpendicular line has slope minus 1 over what? 3/7, right? And what's that equal to? If we have 1 over a fraction, how do we simplify that? It's kind of fun once you start. No one knows? How can I rewrite minus 1 over 3/7? Minus blank over blank. What's blank? What's blank? What's the numerator? 7. All right. And the denominator? 3. So when we reciprocate a fraction, we just flip it, right? The minus stays out front. So the 1 over 3/7 is 7/3. And so the slope is minus 7/3. And we also have the point minus 5/3 is on the line. So by point slope, we get y equals to 3 minus 7/3 x minus a minus 5, right? So y equals to minus 7/3 x plus 3. How many minuses? 1, 2, 3 in that product, right? So I get a minus overall there, minus 35/3. How many thirds is 3? 9/3, right? So 9 minus 35 is 26? Minus 26, I think. So I believe the answer is minus 7/3 x minus 26 over 3. Do you need me to graph this, or does it matter? No? Okay. So my wife was teaching my 7-year-old, I think, history, like Monday, I guess it was. So we're going to take days off, you know. And she was telling him about the Boston Tea Party, you know. And she got to the end of it, and he just looked so confused. And she's like, what? He's like, where was the party? He's like, fish don't like tea. Like, where's the party? And I thought, that's a fantastic question. Why is it called the Boston Tea Party? You know? It's a good question. I mean, I think if any, it should be like Boston vandalism or something. I don't know. It's a very historically well-known act of vandalism, I suppose. It's not really a party so much. Although maybe I haven't been to enough parties. Maybe most really good parties involve some group act of vandalism. I don't know. I generally don't like parties. The idea of going where a lot of people are and trying to talk to them with like loud noise doesn't give me joy. So. Similar comments apply to bowling alleys. But I like bowling, so that kind of balances it. I don't know. So I guess if you have a date that you don't really want to talk to, but you need to kill some time, like bowling alley is a good choice, right? You're spending time with them, but you can't really talk to them. No? You guys are not interested in my advice. I have other advice. Like, you should set the bar low. So like some of you, if you have a significant other, you're going to try to like take him or her to like a fancy restaurant, right? This is wrong because you got to be in it for the long haul. You need to start low. You got to start at McDonald's, Arby's. I mean, you can splurge and take them to Panera Breads from time to time, but you know, you got to set that bar low because you got to think about decades, right? If it works out. If you set, well, if they don't come back the next time, it wasn't meant to be. You just gotta. That's another important point. Is you have to, you know, like you have to be chill. You can't be desperate. Like desperation, that's just gonna drive them away anyway, and waste your money. So like, be cheap and don't care. It's the secret to success. So. Work for me. No, I'm just kidding. Your example 7. Somehow I'm married. Let's see your example 7. Okay, so let's find, suppose line goes through, yeah, I mean, you don't take my advice. Let's see here, goes through